Summary of thermal properties of matter. Heat is a form of energy that flow between a body and its surrounding medium by virtue of temperature difference between them. The degree of hotness of the body is quantitatively represented by the temperature. A temperature measuring device makes use of some measurable property called thermometric property that changes with temperature. Different thermometer lead to different temperature scales. To construct a thermometer scale, two fixed points are chosen and assigned some arbitrary values of temperature. The two numbers fix the origin of the scale and size of its unit. The Celsius temperature and Fahrenheit temperature are related by temperature of Fahrenheit is 9 by 5 temperature of Celsius plus 32. The ideal gas equation connecting pressure, volume and absolute temperature is PV is equal to nRT. In the absolute temperature scale, the zero of the scale corresponds to the temperature where every substance in nature has the least possible molecular activity. The Kelvin absolute temperature scale has the same unit size as the Celsius scale but differ in the origin, that is T Celsius is T minus 273.15. The coefficient of linear expansion and volume expansion are defined by relation delta L by L is equal to alpha delta T, delta V by V, alpha delta V. And in the same way, the areal expansion is given by delta A by A, alpha delta T, where delta L, delta V, delta A denote the change in length, volume, area for a temperature change delta T. The relation between them is alpha volume is 3 times of alpha length. In similar way, alpha area is 2 times of alpha length. The specific heat capacity of a substance is defined by S is equal to 1 by m delta Q by delta T, where m is mass of the substance, delta Q is heat required to change the temperature by delta T. The molar specific heat capacity of substance is given by 1 by mu delta Q by delta T. That is the amount of heat required to increase the temperature of one mass of the substance to 1 Kelvin. Okay. Latent heat of fusion is the heat per unit mass required to change a substance from solid into liquid at the same temperature and pressure. The latent heat of vaporization is the heat per unit mass required to change a substance from liquid to vapor state without changing the temperature and pressure. In conduction, heat is transferred between neighboring parts of a body through molecular collision without any flow of matter. For a bar of length L and uniform cross-section area with its ends maintained at temperature C and temperature D, the rate of flow of heat is given by Ka Tc minus Td by L. That is, rate of flow of heat is proportionality constant thermal conductivity, area of cross-section, temperature difference between both ends and divided by length of the wire or the conductor. Newton law of cooling says that the rate of cooling of a body is proportional to excess temperature of the body over the surrounding, that is dq by dt is equal to minus k T2 minus T1, where T2 is the average temperature. No? T1 is the temperature of the surrounding medium and T2 is temperature of the body. Now we are given some quantities, symbol, dimension, unit and remark. Let's have a look. Amount of substance, mu, mole. Celsius temperature, Kelvin, unit are degree Celsius. Kelvin absolute temperature, Kelvin, sorry I said Kelvin, that was the symbol K of the dimension. That is T minus 273.15. Coefficient of linear expansion, that is K inverse. Coefficient of volume expansion, also K inverse, because that's the rate of change of temperature. Now heat supplied to the system is m L2 T minus 2, unit are joule. Specific heat capacity, joule per kg per Kelvin. Thermal conductivity, joule per second per Kelvin. That's minus Ka dt by dx.